So let's look at the universe and why it's so interesting that we've detected gravitational waves. So this is a representation of the evolution of the universe through time. That bright, brilliant spot on the left is the Big Bang. Many people understand the Big Bang to mean that the stuff in the universe exploded to fill existing space. And that's not precisely it. It is space-time itself evolving. Time, if you will, started at that point. Time is the flow of the evolution of the universe. And so as the universe evolved and began, it started to eventually, after a few billion years, look like what we see now. For this moment, you can consider two separate ideas. One is sort of the atoms, the galaxies, the stars, etc., in the universe, and this canonical grid-like structure on this image as sort of the background of space-time. We'll call this background universe for a moment. So the Big Bang is everything together evolving, the stuff within the universe evolving, but the universe itself expanding. This is important. We live in an explosion. So everything we understand about the universe primarily comes from seeing it. Seeing it meaning using light, using the electromagnetic spectrum to see it. So what we call visible light is simply a small piece of a large spectrum of phenomena. Visible light is the light that our eyeballs are able to detect. Most of light our eyeballs are not able to detect, but we've built instruments that can look at a very wide spectrum of different phenomena through the electromagnetic spectrum. So what we do is we take the information carried by light, run it through detectors, and then we're able to understand something about the objects that have created this light. And at the same time, if we look at a lot of objects, we can understand something about the very fundamental nature of space-time itself that contains these objects. Because in reality, objects, space-time, are not separate. They're connected. They're the same thing. So what happened in September 14th, 2015, the universe spoke and we were able to hear it for the first time. You can imagine the image of a bowling ball sitting on a trampoline, creating a distortion. This is what mass does to space-time. This is what we call gravity, a distortion in space-time. And now you can imagine two bowling balls on a trampoline spinning around each other. You might imagine that the trampoline would have some distortion. These distortions are what we call gravitational waves. So in particular, there were two black holes that merged together, something like this. As they approached and got closer, the distortions in space-time were greater. And the moment that they came together and merged and coalesced, there was a large release of energy. And then once a single sphere was formed again, the energy was gone. Just the simple trampoline holding a bowling ball. Simple idea, profound consequences. It's as if, as a species, we have awoken a second sensory organ. We can hear the universe now for the first time. What does this mean? Short answer, we don't know. Has the potential to completely shift our understanding of the universe. See, because the work that we've done with light has given us pretty good understanding of about 5% of the universe. The other 95% is essentially a mystery. So what will come from using our second sense could unlock 95% of the universe. Understanding the universe is understanding ourselves. So let's end this with just a few words from Einstein. I'll read it aloud. A human being is part of a whole, called by us universe, a part limited in space and time, She experiences herself through thoughts and feelings as something separated from the rest. A kind of optical delusion of consciousness. The striving to free oneself from this delusion is one of the issues of true religion. Not to nourish the delusion, but to overcome it is the way to reach attainable measure of peace of mind.